Well, hi, in this film I'm going to show you the melting of aluminium with my tilting crucible furnace. And this is an old furnace that I picked up. It was running on natural gas and I've had to convert it to liquid propane gas. It does do the job, and here I'm actually melting some car alternators. They're quite a good source of clean aluminium. And I'm pouring it into one of my moulding boxes. That's full of sand. It's actually oil bonded sand. And I've made some wooden patterns for a couple of tools that I wanted, so that's what I'm doing. I'm basically melting the aluminium in the furnace and then casting it in the sand moulds. I had great trouble with this furnace actually doing the conversion, and towards the end of this film I'll actually show you some of the components I used to rebuild it. But it did take, it seemed like forever trying to sort it out. So I now know all about furnaces, but I have to say it was a hassle. It was obviously so much cheaper than trying to buy one of these, because they are expensive to buy if you get one new. Well, having poured the metal, I'm now going to let it cool down. You can see actually this is oil bonded sand, and you can see where the sand has got slightly scorched by the metal around the edge. With the excess metal, I didn't have much left over as it happens. I poured into a cake tin, so those ingots, they're nice clean ones. I can use those again later on. I use some Eco Flux to actually clean out the metal, and this kitchen server is my drossing ladle, and that's the parlour dross. So quite a lot of scrap here. Quite a lot of it, because these are actually alternator car parts. It's little discs of different metal which came out, but I mean, that's great. Having poured the metal, it's always rather exciting to see how it's gone when you try and get the sand out. The sand is actually, holds its heat for quite a long time, so one does have to be a bit careful. And as you can see here, it's steaming away a bit. I always wear some really good quality gloves for this piece, because it does hold the heat, and before you know it, you've got to burn your fingers. This is a casting for a trapping plane. And you can probably work out the centre bit where my hand is now is the actual trapping plane body, and then the bits of metal at each side is the runner and the riser. So my hand is holding the riser at the moment, and those basically pour the metal down one hole called the runner, and then it comes back up through the riser, which is the other sort of rod. So those two rods will get cut off, and I'll just be left that central section, which is the actual trapping plane body. And then I'll attach handles to the trapping plane. It's quite an involved process actually, and it takes quite a long time. That's where the blade goes, this is where the handles go, and these bits get cut off. Well, here's a view of the new innards that I put in the furnace, and I tried initially actually just changing the gas nipple to actually go with a slightly smaller nipple size, and that didn't worked terribly well. In theory it should have worked, but I decided then actually let's get a new gas valve in, because it's safer, it has a flame failure device on it, and I actually renewed all the sort of burner components. So I'll run through what they are and what each bit does. Well, the heart of the furnace is this burner head, and it's a fairly meaty bit of equipment. It's actually got a pilot burner on the side here, so there'll be two pipes going into this, one for the main gas supply and the other for the pilot, and it's got a little electronic ignition thingy on the side here to get a spark to get it going with an HT lead. The actual burner itself is it's the same as like in the motorcycle carburettor. Actually, it's an Amor type jet. So basically the gas comes through, goes through that jet, and then it's a natural draft furnace, so it mixes with the air, goes up and lights the crucible. But that's the gist of the actual burner assembly. There's a thermocouple. Now the idea of the thermocouple, you get these on gas boilers and things. Essentially it sits close to the pilot flame, and as that little tip heats, it sends a little electrical signal to an electronic switch. If the pilot goes out, the signal stops, and the little electronic switch says, switch the gas supply off. So it's a safety feature, basically. You get these on fridges as well, actually, thermocouples. Get them on lots of things. But that's what the thermocouple's all about, so it's a safety feature there. The actual gas switch itself, the control switch, is quite a sophisticated bit of kit, really. So it's got the main gas inlet, and then underneath it's got the connections for the pilot, for the main gas burner, and for the thermocouple. And it's one of these, it's a bit like on a gas fire where you fire with one button, get the pilot going, and then get your main burner up or down with the other switch. So that's the main burner switch. And then there's the gas intake from the propane bottle, and it's just a standard main stopcock. Some bolts to hold it onto the casing with a little olive on the end here to connect up. So that's the sort of idea. It's all got to join all this lot up, and I've got some tubing, one for the pilot, the thin copper, and one for the main burner, the thicker one. So what I'm going to do, I'm going to get my old furnace out, I'm going to rip out the existing gas supply fittings and put all this new stuff in it. I just wanted to say one sort of safety point really, regardless of what the sort of law is in your own country, do get this sort of work checked over by a qualified person. In the UK there are people who are registered to look at gas products, but also very specifically for looking at LPG products, and it really is wise to get someone to check your work and make sure it's all safe. And please do not rely just on what I'm saying on this video.